lines with one intercept. So graphing lines with only one intercept. And before we start, let's just recap our gradient intercept form equation for a straight line, which is y equals mx plus c, where y is the y coordinate, m is the gradient, which is the steepness of the slope, x is the x coordinate, and c is the y intercept. So it's the point where our line is connecting or passing through our y-axis. And that's important to know. It's important that we have a thorough understanding of the role that these play. So obviously the gradient determines where our next x-coordinate will be. So if it's plus 2, it's always going to be 2 times the x-coordinate. Then adding on the y-intercept value to get our y-coordinate. So x and y are relative to each other because we need to find x to find y, and likewise because we need 2 points on the graph to be able to graph them, and they are known as x and y. So lines with one intercept, well, if we just look at the y-intercept, we could just write that as y equals c. That's one intercept. And if you have a look at our first question over here, sketch the graph of the following horizontal and vertical lines. We've got y equals 3. So on our Cartesian plane, we've only got a single coordinate point. So draw a Cartesian plane that is only going to go up in singles there's our y. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's our x-axis. So where does this line go? That's the question that everybody asks. We know that y equals 3, and down here we said that y equals c. So there's no gradient. We've got a point here on our axis, but where is the mx? Where's our gradient times our x-coordinate? Well, our x-coordinate is 0. So don't forget that our x-coordinate is 0. So in actual fact, this question is y equals a gradient of 0 times our x-coordinate plus 3. Well, in actual fact, if that's our coordinate, it's going to be an unknown gradient times 0. Either way, that piece in here doesn't exist. It's just y equals 3. So if there's no gradient, then the line's going to be horizontal. And it's going to pass through the y-axis parallel to the x-axis. And now I don't have a ruler, so that's not perfectly parallel, but that is essentially the method that you have to follow. So that graph there, that line there, is y equals 3. What about x equals negative 4? Why do we have x? We've been working with y equals mx plus c this whole time. Now we have x equals negative 4. What does that mean? Well, it means that our x-coordinate is at negative 4. So I could do this in a different color on the same graph. That's this point here. I'm going to do it in blue. So this one is going to be a vertical line. It's going to run parallel with our y-axis. Try and get this one nice and straight. It's not too bad. So that's parallel with our y-axis, perpendicular to our x-axis. X equals -4. So again, our gradient in this one is what's called undefined, right? You can't have a fully vertical gradient. A gradient that is flat, perfectly flat, horizontal is 0, and a gradient that is perfectly vertical is undefined. Another type of question you might see is sketch the graph of y equals 3x. Now, what are we missing? We're missing plus c, aren't we? Y equals mx plus c. We're missing this part. So y equals 3x. We've got a gradient this time. We have a gradient. But we have no c. What could c be? What value makes something disappear? 0. So we could rewrite this as y equals 3x plus 0. But that 0 holds no value. But that gives us the answer of c. So that means our line passes through 0. If it's the y-intercept, x always has to be 0 as well. So it actually passes through point 0, 0, which is called our origin. So on our graph, we're going to have a line that passes perfectly through the center of our Cartesian plane. Tell you what, that's a pretty good graph considering I don't have a ruler. So then how do we use 3x? There are two ways to do this. The first way is we can let x equal a second point. We'll just say let x equal 1. 1's a nice point. It's the next point after 0. So we're going to be increasing our x coordinate by 1. So if x equals 1, and our formula is y equals 3x, then y equals 3 times 1, so then y has to equal 3. So our coordinate is 1, 3. So on our Cartesian plane, we'll need to mark out our points. 1, 3. There it is there. Okay. The other way we can do it is if we have a look at the gradient. The gradient is 3. Okay. Remember, the gradient is equal to the rise over the run. Now, if we've got 3, 3 is the same as 3 over 1. So we could, from our original point, move up 3. 1, 2, 3. And then run 1. And that's going to give us the same line. So there's two ways of doing it. First way, substitute a value in for x into your formula. Carry it out. You get a y value. You get your sets of coordinates that way. The second way is to make your gradient into a fraction, follow the rise over run, and then count up that many spots on your Cartesian plane, and then across that many spots on your Cartesian plane. The only difference is, if that happens to be a negative gradient, instead of counting up, you're going to count down. All right, so there's two ways that you can solve it. Then obviously the final piece is to draw the line of best fit, which only 2 points, should pass straight through. That's terrible. They barely even touched our origin. But there you have it. There is the line of y equals 3x. So if your line and your graph looks a lot better than mine. And that is how you draw a line with only one intercept. You've either got an origin intercept, 0, 0, or before you have a vertical or horizontal intercept.